All right, Vu, should I start? Okay. Morning, everyone. My name is Peter Nam, and I'm the CEO of a company called Vorsteiner and Gunther Werks. So, go ahead. So I want to give you a little background about my other company, Vorsteiner, which is really where it all started. 15 years ago, we are a US-based composite and wheel manufacturer, so we do tuning for a lot of European-focused cars, all the way from Lamborghini, Porsche, Audi, Mercedes, Bentley, Ferraris, and so forth. And we are one of the few manufacturers that still have a facility in Orange County, and we make everything 100% in our facility in California. So at this time, Vorsteiner sells in 50 different countries. We are actually a TÜV-approved manufacturer for our wheels. And what differentiates us is we have we use a lot of the latest technology to develop our products. We use a combination of clay modeling and CAD, and we even do CFD testing. So you see right here, this is actually our GT4 that we've run it through a CFD testing analysis to see the effects of the aero on the car. And we're using the latest 3D blue light laser scanning to do all this. So, why Porsche? So, you know, I've driven pretty much all the modern European cars, all the way from Lamborghinis to McLarens and Ferraris, and every time I get into one of these supercars, I always just sort of gravitate back to Porsche, and particularly the GT3. And I feel like Porsche is like one of the last manufacturers that are able to build a car, a modern car, that still feels like it has a connection to the driver. So when I drive Lamborghinis and McLarens, they're very, very quick, but you don't feel that connection to that car. That steering feel is not there. The ergonomics are not there. And it's just, every time I always just sort of say, you know what, I love the GT3. So one of the big things for me also is power to weight. Porsche doesn't always produce the highest horsepower in that category, but for some reason they're able to put that power to the ground. And even if there's a car that has less horsepower, you know, like a turbo compared to a Huracan, you'll see the Turbo S have better performance times just because Porsche has figured out a way to translate that power into a car most efficiently than at any other manufacturer. So, you know, this is kind of one of the roots of why I started Gunther Werks and built the 400R, because we're in a phase where cars are going from this analog to digital phase. And right now you see cars like the Teslas, you know, or a lot of the modern cars right now, they're basically, it feels like you're driving a video game. You don't feel like you're driving a car. It feels like the car is driving you. And you're just sort of there along the ride. So I think that a lot of things in modern cars, as we go to more, you know, digitally oriented cars, we're sort of losing that connection, that emotional, you know, connection with that car, and that purest driving feel that we have. And I actually have two boys myself. They're 5 and 6 years old, and I'm actually concerned that in 10 years, they won't need a driver's license because it's an autonomous car, and they're going to go on their iPhone, and the car is just going to pick them up, and people won't need to drive cars anymore. And you know, Tesla's, not to discredit them, they make great modern cars, but essentially it's a computer with 4 wheels. You don't feel any kind of, you know, driving emotion, sensation with that car. So I wanted to sort of create this car to bridge that gap between an analog and digital car, because a lot of the times when you look at a classic car and it looks great in the garage and it's so beautiful, then you take it out for a drive or you take it to work and you miss a lot of the modern amenities like Bluetooth, you know, satellite radio, axle lift, nose lift system, headlights being outdated. So what I wanted to do is I wanted to create an analog car in a digital world where it has all of the sensations and what we love about the analog cars, but we brought in modern technology to sort of bridge that gap together. So that's really what the 400R is all about. So these are some concept sketches that we initially did of the car. That is actually not my hand. My hands are very stubby and ugly, so I actually hired one of my employees to pretend he was sketching the car. So this is kind of how the whole car started. It's based on a 1995 Carrera 2. And we have Martin over here, who does actually a lot of scanning for a lot of big manufacturers. And what he does initially is he takes this white powder spray and he sprays this entire car with this white powdery material. The reason we do that is because if that surface is reflective, he cannot capture that scan data. So what he does is he starts powdering this car to give it that sort of more matte finish. And he puts these tiny little dot stickers literally all over the car so that it creates scan points for the blue light laser scanner. So this is the apparatus that is used to house the head. That is a blue light laser scanning system. Believe it or not, actually, Porsche and a lot of OE manufacturers develop the cars pretty much in the exact same way. Porsche would develop a clay model, and then they would actually put these stickers all over the car and blue light laser scan it and bring it back into a digital environment. So this is the initial. This is a photo of the inside of the trunk, I believe, and that's where you see that blue light laser scanning system scanning the actual car. And this is actually what comes out. This is, you see all these different dots right there, and that's actually capturing the surface data of the car, so we have a full scan of the car on the exterior. So these are actually the mock-up wheels that we started with. So what we didn't want to do is I didn't want to build a car that we built the body and made it look beautiful, and then we're like, oh, you know what? Let's try and fit some wheels on it and hope that the track and everything is set up correctly. We did quite the opposite because of, thanks to Jeff Gamroth over there, he told us that the key part of building a performance 911 is to have a square track. Now, a lot of 911s have sort of that weakness where the front track is always narrower than the rear. So if you look at Porsche race cars, their track, front and rear, is actually very, very close to being square or perfectly square. So what we did is we put these mock-up wheels on the car once we scanned it, and then we use the outer suspension joints. So a lot of people don't know this, but Porsche actually has two suspension mounting points. And the reason there is an outer mounting point on the Porsches is because Porsche uses the outer mounting points to widen the track on all of their race cars. So the reason why production cars don't have that is they're not utilizing that full track. And Porsche had to have that outer mounting point to be homologated for racing. So all the production cars that Porsche ever produced have two different mounting points. It's 964, right? And 993, Jeff? Yeah. So what we started is we widened it, we used the outer suspension mounting points, set up the suspension and mocked it up, then put the wheels on and made sure that the front and rear were as square as possible. And then from there, we developed the fenders. So it's a lot of other companies do it the other way around. They start building the body and then they try and work out the wheels. We did it the other way around. We set up the wheels, the suspension, then built the body around it. So it's a case of form follows function. So here you have, this is actually a rear fender flare that you're looking at. That's part of the rear bumper. And what we did is we CAD designed the rear fenders, and we use CNC technology to actually mill out the fender flares in ABS plastic. Then we would reattach the fender flares back onto the body of the car, and then we would go in with clay modeling and actually refine the surface between the actual fender flare and the body to make sure that it's absolutely perfect. So the guy that actually did the clay modeling on these rear fenders, he worked for a lot of OE manufacturers like Aston Martin, Volkswagen, Audi. So he's actually developed a lot of OE manufacturing cars, and we brought him on this project to do the fenders. He's got a career building fenders. So this, can you go back to that slide right here? This is really the key. This is where a lot of purists, Porsche purists, go to right away. That fender arch, that inner fender arch right here that you see, This is where a lot of people make mistakes. They don't capture that radius of what Porsche did on that fender flare once it rolls into the inner wheel liner. And what we did to keep those lines is we laser scanned it and brought that surface out to make sure that the curvature of that outer fender flare is exactly like Porsche. So this is the front fender flare that has been just attached, and now we're actually surfacing the clay to blend the ABS fender flare into the front fender. And you can see the difference in width between the stock fender and the new fender. And it's about 3 inches wide, wider than the factory fender. And this was a very tricky one because I wanted to kind of look at the Porsche 959 and the Carrera GT, which has a wider front fender. It was a combination of having some of that Carrera GT flatness on the top with some shapes of the Porsche 959, which inspired us to kind of create the shape. And a lot of details are taken into account. Like if you look at the 12 o'clock fender right here, and you go down here, this taper from top to bottom is exactly the same as the same taper as the original factory front fender. So you see a lot of wide body kits where the tapering is not correct and it looks aftermarket. We really wanted to maintain that Porsche factory design language, and we had captured all of the correct tapers and the angles and the curvatures. We also, one of the things I didn't like about the Porsche 993, because it was made back in 1995, is they had this rubber liner that sat right here. And what happens is after a few years, they start getting chalky and white and dried out. So what I did is I removed that gasket, that rubber gasket between the fender and the bumper, and we had tightened up all of the gaps, the body gaps, to essentially 991 standards, so that you don't need that gasket anymore. So this was quite a challenging part of the rear bumper. This is, so we had obviously relocated the exhaust that sit on the left and right side, and we made a center exhaust. But the challenge that I had with the center exhaust is the license plate would get really, really short. Especially when you use a European license plate, it's nice and skinny and wide. But when you put an American US license plate on it, the bottom of the license plate was too close to the exhaust tips. So what we had to do is slightly lower the location of the muffler and the exhaust tip, and have enough painted surface between the bottom of the license plate and that exhaust tip, so that the license plate wasn't sitting too close to the exhaust tip for visual reasons mostly. And we had developed, initially this was flat. The surface area was flat, but it just looked too heavy and bulky. And this rear bumper is about 1 inch lower than the factory. So I wanted to break up that space and surface by adding a ventilation system in there. This is actually functional because it actually releases a lot of heat from the engine and the exhaust. And there are some sort of design elements that you see on like a Porsche Cayman or Boxster, where you have those exhaust ventilation openings over there. So this is the rear bumper, and you could see we were also playing around with the license plate cutout. So on the left side, we kind of went with a little bit more of a modern 997 angular feel, as opposed to the right side over there. It's a little bit more straight, a little more period correct 993. So we bounced around ideas, and we ended up with kind of a little more of a modern 997 license plate cutout, where it just angles downwards. And you could see the surface here. This is where we haven't really done the opening, and it looks a little heavy. This is the rear fender. This is actually where the tape line is, where the actual fender flare was attached, and this is the area that we blended back into the body. And lines like this, we have this S-curve right here. So what a lot of other manufacturers would do is they would just go straight and go across, and it would look sort of bulky. So what we wanted to do was create this sort of S-curve line where it's still the same width, but it blends in more, and it looks more organic. So this is the front bumper clay modeling that we did on one side, and once we've done one side of the clay, we would digitally scan it and actually reproduce it on the other side. So the reason why we do this one side and reproduce the other side is we want things to be 100% symmetrical. So if you do things by hand, there's only so much accuracy you can have with being able to reproduce what you've done on one side to the other side. And every time I see hand-produced cars, I can notice things like, oh yeah, that curvature is 1 millimeter different than the other curvature. So in order to have complete accuracy, we have a center line right here. We have the tape marks. We scan this out of the car and basically flip it over to the other side. And I've taken some elements of the GT3. I've looked at a lot of water-cooled GT3 cars and looked at how the openings are designed and try and translate that into the Porsche 993, because the goal of this project was really to build the 993 GT3 RS that Porsche had never built, an air-cooled GT3 RS. So this was a very, very challenging design because I'm used to developing designs for modern cars like Lamborghini Huracans, McLarens, Ferraris. Everything we did in Vorstaner is going as modern as possible. But this was quite the opposite. I had to design this thing where it looked like it came out of 1995. And we also had to guess, how would Porsche design a GT3 RS back in 1995? How would they design it? What would it look like? So I had studied all the GT3 designs and also looked at the Carrera GT and the 959s and sort of combined elements of each of these cars and tried to make it as period as correct as possible. One of the things I'm particularly proud of is this highlight right here. You can't really see this in clay, but that highlight right there is very characteristic of the Porsche Carrera GT. And the opening style is a combination of 997, a little bit of Carrera GT sort of in there. The guy that actually clay modeled this happened to be one of the head clay modelers for the Porsche Carrera GT. He used to work for the Porsche Design Studio. That's why when I asked him to do something, he immediately got it. So this is the clay modeling of the wing. This guy actually used to work for Tesla, but this was a very, very tricky part of the design because the wing is so organic. There's hardly any sharp lines. So everything was very, very round. And what we did is we started off with a 993 GT2 wing, which Porsche had already engineered and designed to be very, very efficient. And we had sort of readapted that wing to make it more sleeker and functional for this car. So the side of this intake is sort of inspired by a military jet engine. It's kind of the concept behind it. So the angle of this intake is absolutely critical. We want to make sure that the air flows over the fender and angles correctly into that intake opening. And we had created a little light crease line here because if this was too radius, it just looked too heavy. It started looking like a water jug. So we had to add this crease line here to sort of break that surface up. And you see the opening right here. This is where the end caps are for the wing, where the wing attaches. And those 3 holes there are the 3 different mounting points to adjust the attack angle of the wing blade depending on the track that you're in. And this is a close-up of the rear bumper. So the entire car is made out of carbon fiber with the exception of the doors and the mirrors. And the reason why we haven't done the doors is because Porsche has built a side impact beam into the door. And for homologation reasons, if we are to do this conversion, there are some countries that we won't be able to export to without that side beam impact collision. So the doors actually weigh, what, 200 pounds, Jeff? Something like that?
They're almost 100 pounds
Yeah, 100 pounds each. So the doors are actually very, very heavy. But the whole car, even the roof, is made out of carbon fiber. We took out the factory sunroof and saved about 45 pounds and made a carbon roof. So what we did is we cut out the actual sunroof itself with the skin, and we had left just enough over here to bleed that carbon fiber surface back in. So you don't want to cut it all the way to the edge. You want to leave a little border around it. And then you see these pins are actually the locators that we use to bond and glue the roof onto the surface of the body. So this glue is the same sort of glue that Ferrari, Porsche, and BMW uses to bond composite to steel body panels. And then this is further along the phase where this is actually now the production part. So once we've developed and designed and machined out all the body panels and we're happy with it, we made all of the production tooling in-house. And these are the first carbon fiber parts that we've actually completely primered, but there are carbon fiber underneath. And this is sort of the first test fit of the production parts on the actual car. We've reproduced the hood in carbon fiber as well, and we used a 4x4 carbon fiber weave just to create a little bit of shock factor. We use, on the edges of the hood, what we call unidirectional carbon. So unidirectional carbon is carbon that is basically going in a straight line. And the reason why we use unidirectional is on the edges to create strength. Instead of using a weave carbon, you want to use what we call UD carbon, unidirectional, to create more strength so the hood does not bow or sort of warp out of shape. This was the original interior before what you see here today. It was a tan interior, and we started ripping out all the interior and taking out that carpet. That was just a complete nightmare. That glue that Porsche used back then in 1995 was just I don't look forward to doing that again. So we also wanted to develop a new headlight system. So what I wanted to do is I wanted the car to look like it was 1995, but when you got up close, I wanted to create elements where there was modern technology. But from far away, it looks like a car from 1995, a period correct car. But when you get up close, you see details like the headlights. That is the latest LED technology. We wanted to skip the xenon system and go straight into LED. So this is actually the first time we developed this housing where it's made out of 3D printed aluminum. So it's a metal printer that actually prints aluminum, titanium, magnesium, and we had started with an aluminum one. So what it does, it starts printing, it uses laser and powdered metal to start developing surface, and it just starts going from down here to up here. And then the blue area is the break-off surface, because obviously this thing can't just be floating in outer space. So these are the break-off areas that are a little bit weaker so that you could break the actual, extra material off, which is essentially acting as a stand. And the next picture is the actual 3D printed aluminum headlight housing right here. This is the first version that we did. I actually had to hand brush this myself, and that's why it doesn't look that good. I had a lot of practice with brushing my watches, but obviously, and this is the second version of the headlights. So this is the production version. So what we did is we got rid of the 4 LED corner lights because the reason we had to do that is we wanted to use a bi-LED projector. So this is one of the latest bi-LED projectors that are out there right now that we integrate into the system, and this had to grow in size. So we couldn't do the 4 corner LED lights like you see on a lot of the modern Porsches. And we created an aluminum heat sink here. This is ventilated right here to extract heat. This bezel is also made out of aluminum, and we also created a bezel on the outside with an LED halo to hark back to sort of the more modern 991 Porsches. This is the first time we made headlights, so this was interesting. We had to make our own glass because the factory glass on the 993 has a lot of diffusion lines on it, and Porsche did that essentially to hide some of the ugly guts behind the headlights, and we wanted to make the headlight lens completely clear. So we went to a local supplier that actually makes glass for a lot of concept cars. He used to work at Metal Crafters. And he's one of the few guys in the country that actually has a glass oven. He can make windshields and roofs and headlight lens and so forth. Go back to that slide right there. So what we start doing is we use a 5mm, John, right? 5mm glass. So typical windshield glass is actually 3mm, but we used a 5mm for durability reasons, for impact. And so that was one of the biggest challenges we had, is to develop this sort of spherical shape that is as close to that Porsche glass as possible. But trying to do that with a 5mm glass is extremely challenging. So to have one pair of glass lens, we have to break about 8 to 9 sets because this is all essentially handmade. And it goes, we put in the oven in this flat shape. It goes into a mold, and we bake it in the oven, and it turns out in this glass curvature. One of the things that was a little bit frustrating was that Porsche has a left and right side glass. And there is only a 3mm difference in the 6 o'clock position. And I, for the life of me, can't understand why Porsche insists on doing this. They change things where you can't even understand why they changed it, but that's just how obsessive they are. So we had to make a left and a right side glass lens, and initially we had to label them because they're so different you can't tell, and then if we put the right lens on the left headlight bucket and you try to put it in, the orientation of the headlight would be off. It would be a little bit counterclockwise. And we're like, oh my God, we put the passenger side lens on the driver's side. So we're like, okay, we're going to have to start labeling these things so we don't mix up the two. The next slide actually shows, this is actually the oven that bakes the headlight glass lens. And these are some of the components involved with the headlight. So what we did is we used the factory Porsche 993 bucket with all the clip mounts, so that we wanted to make this headlight serviceable. We wanted this headlight where you could almost take this to a Porsche dealer. It plugs right into the factory Porsche pins. You could take the back of the bucket out and service the headlight. We don't want to make a Mickey Mouse headlight where there's wires and tape all around it and you're just looking at a big mess. So we wanted this thing to look like it came right out of Porsche. So some of the things we did is we used we developed a carbon fiber housing that we made in-house, and this ring right here is the aluminum bezel that actually houses that LED halo. This is this right here is the heat sink in the bottom and the headlight bezel. And this is actually the bi-LED projector that's much bigger. And on this particular car, we didn't put any clear coat on it. This is actually raw carbon fiber because I kind of wanted to, first of all, I wanted to save weight. Clear coat adds weight, and we kind of wanted to make it look like a 993 Cup car, you know, where the Cup car headlights are carbon fiber and they have no clear coat on it to maximize every weight saving possible. So this is the actual headlight lens. We have the glass here. This is aerospace glass. And we have the original factory plastic gasket that just fits right into our existing headlight housing and closes that gap. And this is the halo and the bi-LED projector headlights. So the interior, we developed our own carbon fiber one-piece bucket seats. They saved, how much was it? About 40 pounds? 40 pounds per seat. We had recovered everything initially in Alcantara and leather with red stitching, so I kind of wanted to play off the way Porsche makes the current GT3s. Everything is Alcantara leather. But We also, played around with the inserts back here, and this is actually houndstooth insert. So the company that makes this is based out of Belgium, and they had reproduced the houndstooth fabric to the exact T. Houndstooth, I don't know if a lot of you guys know, is different from the seat inserts on the Porsche 911R. The 911R, the insert is actually called Pepita. So Pepita is got a little bit of a different pattern, and it's actually made out of seatbelt fabric to make it more durable. But the older cars, they used a fabric called houndstooth. So houndstooth and Pepita are two different things that I just learned recently about. You look at the door handles here. We made our own aluminum door handles, and we cut material out of the center to save weight. So we looked at every area of the car that we could save weight. So this is a 3D scan of the back of the car. So I wanted to remove the rear seats because if this is supposed to be a GT3 RS, we don't want to have rear seats in there. We want to be true to its original concept. So I didn't want to just remove the seats and carpet it. We wanted to, I looked at the weight of the carpet, put it on the scale and said, okay, how much weight can we save by removing the carpet and all this extra glue and all the sound deadening? And what we did is we developed a rear seat delete panel. So we scanned the thing, we designed the rear seat delete panels in CAD, and then we CNC machined it. This is actually the first ABS plastic pieces that came out. And we originally had two squares here where we wanted to reinsert the factory rear speakers. But I just learned during this project that you don't really need rear speakers. All of the modern cars today only have front speakers. So the rear speakers don't really do much for this car. And they weighed about like 7, 8 pounds, right? So we removed the rear speakers and gained some weight savings there. And this is the result of, this is the actual production version of it. We put these creases here not just for looks, but for rigidity. So we actually have a little bit more lamination and strength on these areas, just in case there's like a heavyset guy that decides to sit back there. And then we integrated a fire extinguisher and redesigned these side panels completely and covered them in Alcantara. This is going back here. This is actually, I also looked at carpet too. So I didn't want to just use the same sort of heavy wool carpet from what Porsche used. The reason Porsche uses a very, very heavy wool carpet is it actually hides a lot of imperfections. It's done for cost reasons, and in case some people don't like, they see imperfection in the carpet, Porsche don't want to have that liability. So we used a finer thread carpet, and this carpet is actually the first time it's being used in the automotive space because this is an aerospace carpet. It's actually more fireproof, and it's the lightest carpet available right now for a vehicle interior. So we looked at carpet and weighed 5 or 6 different carpets to find out which one was the lightest and also the most durable. So the front, the same thing. We have, if you ever look at the front of a 993, there's just carpet there. It literally looks like a college dorm room because the carpet is just sort of kind of put in place. It's just sort of wrinkly. We wanted to remove the original factory carpet and resurface it with carbon fiber the same way we did the rear seat delete panel. So we scanned the entire front and developed a new interior trunk liner, what we call a frunk. So this is actually the liner that we used. And we have a compartment right here where we've reinstalled, Jeff will go over it more, but we've reinstalled an electric steering pump. The battery goes up there, and we've sort of shifted some of the weight back there. There's a lot of screws. We just went a little crazy with the screws. In case somebody wants to hide cocaine underneath there or something. Next slide. So we went and developed our own gauges, and one of the gauges that's right in the center is that tack with a 400R. The engine now revs to 7,800 RPM. And we developed these bezels, these aluminum bezels. This is the only cosmetic part that I did because we're selling a $600,000 car and you don't want to see a black plastic ring. So I developed these CNC aluminum bezels, and they have 6 different notches in here to celebrate the 6-cylinder air-cooled engine. And so some of this is stuff that no one has seen yet, but this is the new carbon fiber door panel that we're developing right now that we're working on. It's going to be an option for January. So we're going to replace the existing factory door panels. We're probably going to save about 8 to 10 pounds, and we're going with, it's all carbon fiber. It's got a little bit of an armrest right here. This is an aluminum door handle that we're going to make in CNC. It's going to be attached in the front, and we have a door strap pull to sort of hark back to that sort of GT3 concept. This is another concept that we're working on, and we're kind of going more in this direction. These are the new optional seats that we're working on. So what we did is we took the 997 GT2 seats, which are actually now no longer available, and we took some of the exterior dimensions of that and redeveloped our own carbon fiber one-piece bucket seat. This is a secondary option to the ones that you already see in the car right now. We are going to make the entire skin out of carbon fiber, and this is also, this red portion right here is also made out of carbon fiber, but we're going to pad that and wrap it in leather. We have sort of the 993 GT2 style seat inserts right there with the splits in the middle. So it has sort of a combination of modern Porsche seat design and also the classic period correct 993 GT2 seat designs. And as you can see here, really proud of this achievement. The car is, rear track is 63 inches in the back and 63 inches in the front. So this is one of the few 911s out there in the road that have a completely square track. Another big achievement for us is the power to weight ratio. Power to weight is everything, especially in the GT3. So we looked at some of the other, headline Porsches. We looked at the 964 3.6 RS. Power to weight on that is 209 horsepower per ton. You go to the 993 3.8 RS, that is 236 per ton. And the 959 is where, like in this period, it was 306 horsepower per ton. Which is the highest here, but these are all sort of in the 2s, and then the 959 is in the 3s, 306 horsepower per ton. Then you get into the water-cooled cars, where the 997.2 GT3 was 307 horsepower per ton, almost the same as a 959. 991.1 GT3 is 327 horsepower per ton. Then you have the GT3 RS, which is 347 horsepower per ton. And the brand new 0.2 GT3 is 344.7 per ton. And our car, we've started off with a weight of around 3,170 pounds. And after all of the weight saving measures, we are down to 2,670 pounds, which is lighter than a lot of the 993 race cars. And the power to weight is 351.12 horsepower per ton, which is actually above the 991.1 GT3 RS, which you see back there. So quite happy with that achievement. This is actually what the car originally looked like. It was originally Guards Red, and we repainted that to a color closer to Carmine Red, and you can see the differences. The bumper is obviously much lower. It's obviously grown a lot in width. The car is actually wider than the current GT3, but shorter. And the 400R team, we have Jeff Gamroth, who's standing right here, who's the engine builder and the engineer behind it. Kerry Eisenlohr, who's suspension genius, and same with Joey Seeley. Kerry and Joey both have a tremendous amount of Porsche racing experience. Joey actually is one that used to set up all the race cars for Patrick Long, who's a Porsche Motorsport driver. Next. And I'm going to turn the table over to Jeff Gamroth, the engine builder. He came all the way from Portland, Oregon. And Jeff, thank you for being part of the team.
Thank you. A little bit about myself. Born and raised in Portland. Well, not born, but been there my whole life. Worked on my first Porsche when I was 15. My neighbor had a 67S. I asked him if I could work on it for free, and he said, sure. I said, all I need is the tools and the books. And he said, okay. He paid for those, and I worked on his car for free for years. My whole high school life and a few years of college life. We lost track of each other after I went to college. I did 3 years at a college and then decided I'm done with this. I'm going to go work on Porsches. In 1983, I started working at a Porsche shop. Did that for 15 years, 2 independent places in Portland. After 15 years, I started my own business in 97, and that's where I am now, about 20 years into my own business. The 2 Porsche shops I worked at were service facilities. We did, maintenances, air conditioning, you name it, repairs. I wanted to build custom cars and race cars. I got involved in SCCA racing in 1986 with a customer that brought a car in. Neither one of the 2 shops I worked at wanted to work on race cars. They just wanted to do the service work. So that led me to quit after 15 years of doing that and just basically try starting my own shop. So that's what I did. And all we do now is custom Porsche race cars, vintage race cars, street hot rods, restorations now. That we've gotten into a lot of restorations because of our experience with all the old air-cooled cars. And now the cars are coming back. We're now converting old race cars back into restored street cars now. It's just funny how the whole thing turns. Before, when I started in 97, we would take a brand new M491 turbo look Carrera and just gut it. Take all the parts off of it, build a roll cage, turn it into a race car. Now that car is worth a lot of money, and we're turning them back into street cars, finding all the old parts. I just did an RS America. We've restored multiple 67Ss. We're doing the 67S vintage race car back to a street car. I mean, these cars are crazy money, and people want to turn them back into what they originally once were. And so that's basically what we do. Anything custom and going back to original. During that whole time, on or about 2002 or 3, I built an engine room and created put a dyno test cell in my business, and that's where we started developing a lot of our own parts for the engines and whatnot. That's been kind of that's probably the best money I spent in my shop, just because it gave us the ability to test and develop components that a lot of which you see are now Genesis on this car. My racing career started in the early 80s, and then professionally I ended up getting work from Brumos Porsche in the 90s on the Bridgestone Supercar series, worked with Hans Stuck, Hurley Haywood, and those guys, doing that for a few years. 95, I did some work with Brumos again at the 24 Hours of Daytona. Hans, Hurley, Walter Rural, and Danny Sullivan drove the GT1, which was not the GT1 as most people know. It's the first GT1 was 95. That was a 993 twin turbo. It's actually a single turbo. It was a 993 with a single turbo. They called it the GT1. And that car ran about 17 hours and then failed during that race. That was my first very big disappointment, professionally speaking, racing-wise. After that, I got a job with Alex Job in 1998, and basically worked for him on the professional sports car series, endurance racing series. They called it multiple different names throughout my whole career from the 90s on up, but now it's IMSA. Did that for 6 years. Le Mans, Daytona, Sebring, Silverstone, Rama, multiple races in the world, plus all the races in the United States, Laguna, you know, all the professional venues. Some of the drivers I worked for were, you know, Lucas Lohr, Sasha Maassen, Timo Bernard, Mark Lieb, all the current and some of the current and past factory Porsche drivers. Dirk Mueller came up. He was brand new Porsche driver from the junior team. Timo Bernard, I met him when he was, like, I don't know, 17, 18 years old at Sebring in '98. And now the guy's one of the best in the world. Anyway, after 6 years of doing that, quite frankly, I just got tired of traveling and sitting in airports. So I went back, and during that whole time I had my own business. I decided to concentrate on business and family and all that, and that's where I am now. So in April, these guys call me or May and say, I want to do this car. So, and they want me to be the engine builder. I said, okay. So here we are. A little bit about the engine. The stock motor is, in this car, 95993 is what, 272 horsepower, 3.6 liter, perfect 3.6. Just your standard run-of-the-mill motor. About the only thing we use, we take pretty much everything off the engine and start with the crankcase and a few of the peripheral components. Next slide, MJ. That's a pile of some of the parts that have come off, well, the chassis, but a lot of the engine components and whatnot. And then there's 10 times more than that once we get through with it. The motor, you know, one of the things I regret is not weighing the motor before and after, but I'm guessing the motor's close to 100 pounds lighter, 75 pounds lighter than it originally was. And that's back at the back of the car, so that's an important area to reduce weight. We start with a factory Porsche crankshaft from the 4-liter and go out from there. GT3 oil pump, because of the scavenging improvement, they have dual pickups inside the crankcase. We have custom rods made by Carrillo in the United States. We have custom cylinders made that are 102.7 millimeter bore, which is the factory Porsche 4-liter diameter. I stuck with a lot of what Porsche engineered already, only turned it into the air-cooled package. I even used some Porsche piston rings. The pistons I had made by Molly, custom made for me. The rods are a special spec to make it all packaged nicely. The rods are steel rods by Carrillo. They're very light. They've been weight optimized and all that, so I didn't, because we're not revving this engine to 9,000, I didn't see the need to put titanium rods in and spend the extra money on all that. This is still a 2-valve engine, so you just don't have the rev range that the water-cooled cars have. So the cylinder heads are bespoke custom heads made in the United States. They're cast here, they're machined here. The valves are made here, the springs, everything, titanium retainers. They have a proprietary port design that I developed with the cylinder head maker. And that works with the induction system and the exhaust system. So, you know, the engine's an air pump. As most of you know, you got to get air in, you got to get air out, and the better you manage that air, the more power and torque you'll make. In the late 90s, early 2000s, I was involved with the factory Porsche 993 RSRs and raced them and worked on a lot of them. And that gave me the idea to start my own fuel injection system manufacturing side of my business. And I essentially took elements of what Porsche did on the 993 with the 6 throttles. You can see them right here. Normally on the stock 993, this part right here holds just the fuel injector. It's just a round hole. All it does is connect the plenum to the cylinder head. The factory throttle body is usually located up here, so a single butterfly. The factory race cars use 6 butterflies. That way they could have a proper camshaft in the engine to generate the horsepower. You can't get away with a big, higher horsepower cam with a single butterfly just because of the torque between the cylinders. I call it crosstalk, but with a whole open hole here and an open hole there, you get too much reverberation from the more aggressive cams. So that's why Porsche put 6 butterflies. And even to this day, the modern water-cooled RSRs all have butterflies on the heads, 1 over each port. The plenum is critical. I noticed that right away on my dyno. A lot of guys, ironically, when 993s came out and the 64 RSRs, guys were taking off this plenum and putting individual stacks on them. And eventually they figured out that that was a mistake and went back to plenums. There's a principle that, I don't know who invented it, but it's called the Helmholtz principle. Guy Helmholtz probably invented it, but anyway, it's a resonant tuning effect that's gained from the common plenum. So when the intake valve closes and the air is rushing in, all of a sudden that air now bounces off the back of that intake valve and changes direction. And that principle helps charge the opposite side of the engine when that intake valve opens, and thus increasing torque and airflow into the motor, which then increases your torque and your power. So getting rid of a plenum takes away some of that tuning effect. So having that plenum back on the motor is very important. It broadens the torque band. So in other words, if you looked at an overlay on the dyno graph, you can have a straight stack engine like a 2.7 liter RS motor or a carbureted 2.2 or whatever. You have a fixed length intake tract. That track has its own frequency and it's fixed. You can't change it. With a resonant effect, you can have a valve which this houses inside a butterfly valve, which changes the volume of that plenum, and that actually can change the tuning effect depending on the RPM you have. So you can have your, shall I say, you can have your cake and eat it too. You can have an engine with a lower RPM, you can have plenty of torque and power, and then when the RPM demands it, you know, when your RPMs are in such a range, the computer would switch a valve, and that's and create a different tuning effect, thus enhancing the peak power and torque up on top. This is how all the modern cars are, even the cars with passive plenums. Some of the modern Chevys, BMWs, Mazdas, you name it, any car has, most cars have plenums now that are either active or passive. The Porsche engine, the 95 993 had just a resonant plenum with a single valve in it, the factory engine. The VRAM engine, which would be the 96 and later 993s, have the resonant tuning effect plus a variable length intake tract, and that was to enhance it even further. That was just another level. That intake plenum is extremely heavy and complicated. It's not very aesthetically pleasing, and with the larger increase in displacement, we decided we just don't need the complexity, the weight, and the benefits were less with the variable length intake tract with a motor of this style. So we stayed with the resonant tuning, and we've developed a very broad, torquey engine. And I started doing this years ago, building injection systems, and we use a combination of factory parts and parts that we make. This particular plenum is probably the second one we've made in carbon. Second or third unit, and it's just very light and efficient. And one of the unusual things you'll notice about is that air cleaner. That air cleaner was designed by a company in the UK that builds modern high-performance air cleaner systems for all the latest cars, a company called E. Venturi. And the Vorsteiner guys knew these guys and said, hey, we'd like you to try this air cleaner. Can you adapt it? So yeah, I said, send it over. So we initially built this carbon plenum without a hole in it because I hadn't got the air cleaner yet. We were building the plenum before we had the filter. So there's one of these slides that shows the display motor that was on display at Quail. We didn't have the hole cut in the plenum for the air cleaner. And I guess only one person noticed that there was no hole in the intake system the whole time that thing was on display at the lodge there. After we got the motor on the dyno and built the engine, the deal is we didn't have time to build the engine from May to August and have it running in the car, plus have them be able to tool the car and work on the car with carbon and powder and lasers and clay everywhere. You just couldn't do it. So I built them a mock-up motor with no pistons in it and no cams, and you know, it's just a pretty engine to look at. Put the intake on it with no hole in it, put the exhaust on it, and they had the car on the ground with an engine on the stand. So everything could work because the time compression was incredible. This shot right here that's a one-of-a-kind fan that's made out of a single billet piece of aluminum. We used the 993 turbo fan housing. Maybe I'm digressing here. I should digress a little, I should say. The factory 993 fan has curved blades. From what I've read, that was done to keep the noise down on the engines. They aren't as efficient as a straight blade fan. So we wanted to use the 993 turbo fan housing, which is a different diameter and a completely different shape. The stator, the vanes that are behind it are different. You cannot just put a straight blade fan into a curved blade fan housing. They don't work. So we decided to use the turbofan ring turbo fan. Lo and behold, you can't buy turbo fans anymore. They're out of production right now. So fortunately, a few months prior, I had already been working on this billet fan with a company out of Canada. And long story short, we had this billet fan that was already available, and we decided to put it on in this fan housing. So these are the same weight as the magnesium fan. This is made out of aluminum, hard anodized, and it actually has been CFD'd and FEA'd to death, and the blades have been optimized to make them even better than the original 993 turbo straight blade. The weight is exactly what the magnesium fan is, and they don't corrode and they don't have the paint chipping off them like your current fans do. So the belt system is the multi-rib belt off the 993 RSR. Back when they came out with the 964 and the 993s, Porsche got rid of the V-belt and put a multi-rib belt on. And so we retain that. This shot of the throttle systems. I have the throttle bodies cast for me. They're made in the UK. Then all the billet pieces, the fuel rails, the throttle linkage, throttle rods, all that stuff is made in Oregon. The headers I have made by a company that is really good at making exhaust. One thing I don't want to do is sit and cut metal and TIG weld all day. Just don't have the time. But I come up with a concept, we design things, and we test them on the dyno, and then I go into production, kind of like what these guys did with the car. They have a concept, they clay model it, they look at it, they go, okay, ooh, that looks good. And then they mold it and make it, and you get a finished part. That's basically the same thing we do here. Yeah, I mean, after we got through, the goal, when these guys came to me, they said they want a 400 horsepower engine. And I said, okay, no problem. They'd like it to be 4 liters. I said, okay, no problem. We've made that kind of power. And it has to run on pump gas. It has to look good and sound good, and all of that. So we ended up exceeding their expectations, exceeding my expectations, actually. I did a few things different on this engine that I'd ever done before, and that netted us an engine with a dual path exhaust. We're using the standard GT3 center muffler just because they sound good, they look good, they're available, and we are running both exhaust tracks in them. The GT3 has 3 mufflers. We're using just the center section, and we're taking the 2 inputs into the side and switching them with a valve so that you can have a quiet, non-resonating exhaust versus a much more open, freer flowing exhaust, which nets about 30 horsepower, the quiet mode to the loud mode. Now in the water-cooled engines, that's different, but on the air-cooled motors, it costs some power going so much quieter, mainly because the airflow of this motor and the way it's tuned, it needs that open. You know, we're extracting a lot of horsepower per liter out of an air-cooled 2-valve engine, and you have to have airflow. The water-cooled engines do a tremendously better job at moving air just because of the 4-valve head efficiency and you know, all the engineering they've got built into those engines. But yeah, the net result was 430 horse, very good torque, very flat torque curve. The motor drives more like it doesn't have that broad, flat, benign feeling that the original engine has. You know, the original cars, they kind of torque out of the hole and then they kind of flatten off and you don't get that big top end pull. This engine pulls and you just keep getting pushed back in the seat the higher you go in the RPM band. And that was one of the effects we wanted. If you look at a stock VRAM engine, the horsepower will kind of flatten off and lay there and then roll off above 6,700. So you don't get that top end feel like you have in like a 73 RS or an early 2-liter car, or quite frankly some of the GT3s. They just keep pulling hard, you know, the higher you go on the rev range, and we wanted to kind of mimic that feel and have more of a race car type horsepower curve and what it feeds you back into your mind. So the result was a very broad, torquey engine because of the resonant plenum, and a very high output, very high horsepower up on top, high RPM outcome. And it makes for a very nice driving car. It's a lot of fun. The gearbox is also critical. Putting the power to the ground is important. So we re-geared the whole transmission. Strengthened a few parts inside based on, you know, what we know about those boxes from years of racing and whatnot. Good limited slip and good gear ratios and whatnot. And single mass flywheel. We're using this GT2 RS style clutch in it, just like what's in, well, the 997 GT2 RSs now. So because we still believe in manual shifting here. Yeah, I mean, that's basically it. We use a standalone engine management, and I'm getting the cut sign.